Hello student, today I am going to discuss a very important topic for the revision of chemistry for upcoming JEE and NEET exam 2025. So, N-factor calculations for redox reactions in different situations. First of all, what is redox reactions? Where the oxidations and reduction used to taking place simultaneously. From the reduction side, we used to take red. For the oxidation side, we used to take ox. By combinations, we used to call it as a redox reaction. Why N factor is very important? We know in different titrations related problem, equivalent mass calculations related problem, this N factor is essential. So this formula everywhere is come into the work during the exam time. Equivalence will be equals to number of moles into N factor, where N is a small n is a number of moles, small n is a number of moles, and this NF is a N factor, and E is a equivalence or gram equivalence, whatever we call it, equivalence, or it is called as a gram equivalence, equivalence or gram equivalence. And now again we know that equivalent mass is EM. This EM is a equivalent mass or equivalent weight, whatever you call it. Equivalent weight will be equals to always molar mass. MM means molar mass by N factor. Either these things will be applicable in a different types of problem, or these things will be applicable. So that's why this N factor calculation has a big role for different types of problem attempting in upcoming JEE and NEET exam. So now I will discuss the N factor calculations for different types of redox reactions. Previously already in my equivalent concept it is there for the acid, for base and the salt. Now you can look at these N factor calculation tricks as well as full clarity how to calculate in a different situation of redox reaction. First, let us look at very simple reactions like permanganate. Permanganate means MnO4 minus potassium permanganate. Why I am not writing KMnO4? Potassium ion charge is a +1. It is never going to change in a redox reaction. That's why it is a spectator ion. Only which part is going to change into the redox reaction during the redox reaction, that things we need to write down over here itself. Where the oxidation number is not changing, we will not write. Specifically, N factor is nothing but a particular species of substance or particular atom in a substance, they are gaining of electron tendency or losing of electron tendency is nothing but a N factor. So now there are different situation and cases is there. We will explain that things how to calculate the N factor. Like MnO4 minus, that means permanganate in acidic medium. Acidic medium, it will be converted to always Mn plus 2. Here oxidation state, I hope you know how to find out. You know overall charge is a minus, oxygen 4 into minus 2 minus 8. Definitely manganese has to be +7. Or you can do like that, a manganese is a x plus 2 into minus 2 into 4 equals to overall charge -1. That way also you can calculate. So here manganese is +7 oxidation state. Now this +7 oxidation state is going to the acidic medium Mn plus 2. Now here how I will calculate the N factor? N factor will be equals to change in oxidation state into number of atom associated. Change in oxidation state or oxidation number into number of atom associated. Into number of atom associated. So now no need to balance. Directly you can do these things. So change in oxidation state into number of atom associated. So that's why in this case N factor will be equals to change in oxidation state +7 to +2. How many unit change? 5 unit change. Number of atom, only one manganese atom is there. So that's why N factor is nothing but a 5 for these reactions. Again, if you look at MnO4 minus in neutral medium or slightly basic medium, slightly basic medium, it will be converted to MnO2. So, sir, how I will remember? You have to remember in MnO4 acidic medium where it will convert, in neutral medium where it will convert fast. This is the first and foremost informations you need to remember, because chemistry is a combination of memory and logic. Few things you have to memorize, then only we can put the logic. So that's why MnO4 minus is converting to MnO2 where in neutral medium. This part you have to remember. And then you look at manganese oxidation state over here +7. Here overall is a neutral molecule. Each oxygen atom -2. That's why -2 into 2. So -4. So then manganese obviously will be there. How much? +4 oxidation state. So then +7 is going to +4 oxidation state. Then same way we will calculate the N factor. Change in oxidation state into number of atom associated. Change in oxidation state +7 to +4. How many unit change? 3 unit change. So that's why 3 unit change is there, and how many manganese atom associated? Only 1. So that's why N factor is 3. So if this is they are giving reaction, they are asking what is the equivalent mass of KMnO4 in this particular reaction. N factor 3. Then molar mass, equivalent mass equals to molar mass by N factor. If they ask you what is the equivalent mass of KMnO4 in slightly basic medium or neutral medium, then you will do equivalent mass equals to molar mass of KMnO4 divided by N factor. Here N factor will be equals to what? 3. You can easily calculate, and you can calculate the N factor, and you can overall calculate the equivalent mass. Is it clear? Another important things that MnO4 minus in strong basic medium, strong basic medium, it will be converted to permanganate, will be converted to manganate ion. So which is nothing but a MnO4 2 minus. It is purple violet color, it is green color. Permanganate always purple violet. Some people will say pink type, purple violet color, and this is nothing but a green color. This is a permanganate, this is a manganate. Here manganese is +7 oxidation state, here manganese is +6 oxidation state. So then how you will calculate the N factor? Change in oxidation state into number of atom associated. And always you look at overall charge is 2 minus. If you don't know how to find out oxidation state of manganese, what you will do? You will keep over here x plus 4 into -2, each oxygen atom -2, x plus 4 into -2 equals to overall charge, which is -2. From there you will get the value of x equals to +6. That way you can do always. So that N factor equals to change in oxidation state +7 to +6. 1 unit change, number of atom associated 1. So that's why for this process N factor equals to 1. Here if they ask you equivalent mass equals to KMnO4 or permanganate equals to molar mass by 1. Yes or no? Clear? So then you look at the next situation. In next situation, suppose I am telling dichromate, very important idea I am telling. Dichromate is converting to 2Cr+3. Now this is a redox reaction. So you look at very clearly. Now for this direction N factor, if you look at N factor will be equals to change in oxidation state into number of atom associated. If you calculate here oxidation state of each chromium will be +6. +6 into 2 +12, 7 into -2 -14, overall charge is -2. So now N factor how you will calculate? Change in oxidation state +6 to +3, 3 unit change, number of chromium atom into 2. No need to balance, directly change in oxidation state into number of atom associated. That means dichromate forward direction N factor is coming 6. But here when chromium is coming this direction N factor equals to, you look at change in oxidation state +3 to +6, which is 3 unit. But how many chromium? Here 1 chromium. In that chromium this is a mole of chromium. I am not taking the mole of chromium. Point is clear. Here like that I am not taking the mole of dichromate. How many chromium atom is associated, that is I am taking. Here how many chromium? Only 1. So that's why 3 into 1. So in this direction N factor for this chromium +3 to dichromate is 3. Then only as per the law equivalence both will be equal. We know, suppose this is the reaction is happening, then we can write down equivalence of dichromate equivalence of dichromat will be equals to equivalence of Cr plus 3. You look at and understood this concept. Then equivalence will be equals to number of moles into n factor. Number of moles into n factor. Number of moles into n factor of what? Dichromat for forward directions. Dichromat for forward directions will be equals to number of moles of Cr plus 3 into n factor for Cr plus 3. Now if you look at dichromat, that n factor is 6 forward directions, number of moles is 1, then 1 into here is n factor for dichromat 6. That equivalence, you know, as per the law, equivalence of reactant will be equals to equivalence of product. So that's why both the equivalence should be equal. So that's why here it is 6. That's why number of moles of chromium plus 3, that is 2 into n factor of chromium plus 3, that is 3. Then only you look at they are coming equal. That's why that dichromat forward direction n factor is 6. Chromium plus 3 backward direction n factor is 3. But dichromat forward direction n factor is 6. For that, n factor is 6 for dichromat forward direction, number of moles 1. Chromium plus 3, n factor is 3, but number of moles is 2. That is the idea. Is it clear? This idea is not giving clarity. Lot of places, lot of books, so understood these things very clearly. Is it clear? Okay. Then let us look at the next idea. Like one of the component is undergoing, there are maybe one of the compound has a two part is undergoing oxidation. In that condition, how we will find out overall n factor? Like suppose I am telling ferrous oxalate is converted to iron plus 3 plus CO2. Now, in this case, how I will find out the overall n factor? You look at here, oxidation state of iron is plus 2. Here, each carbon is there in plus 3 oxidation state. Here, each carbon is plus 4 oxidation state. That means both the component, carbon as well as iron, both are undergoing oxidation. If the oxidation state is increasing or oxidation number is increasing, then loss of electron need to happen. Loss of electron is a oxidation. That is a fundamental thing. And oxidation number decreasing means gain of electron is happening. It's a process of reduction. That's why here both the thing is undergoing oxidations. For that purpose, how can I calculate the n factor? So that means my overall n factor, this is one oxidation is going on for these things. So here also carbon is undergoing another oxidation is going on. So suppose here I am telling this is the oxidations 2 and for this is the oxidations. Then overall n factor overall will be equals to n factor for oxidations 1 plus n factor for oxidations 2. That is the idea for the overall n factor calculations for this type of process. If it is undergoing reduction, then same way n factor for overall will be equals to n factor reduction 1 plus n factor reduction 2. That is the idea. So now here I will do the same method. So that means if you consider for this iron if you look at plus 2 is going to plus 3. Same way for the oxidations, n factor for oxidations 1 we are going for calculation. So iron plus 2 is undergoing iron plus 3. Change in oxidation state is 1 unit and 1 iron atom is associated, that's why 1. Plus then for the carbon, I told no need to balance. Directly from that equations we will do. So then from this plus 3 to always look at the reactant. So in respect to reactant, what in the product you look at, what change is there. And in reactant, how many atom is there? Always multiplied by that one. Be careful and remember this point. So that's why plus 3 is going to the plus 4. How many unit? This is for all, okay, over n factor for oxidation 1 is over, which is nothing but 1 we are getting. Then n factor for oxidations 2 calculations. Change in oxidation state plus 3 to plus 4. How many unit change? 1 unit. Then always look for the number of atom in a reactant side. No need to balance. So then how many is there? 2. That's why multiplied by 2, which is coming nothing but a 2. So then n factor overall will be equals to n factor overall, n factor of oxidation 1, which is nothing but a value is 1 plus n factor oxidations 2, which is value is nothing but a 2, 1 plus 2, which is nothing but a overall n factor is 3. Is it clear to everyone? Look at the things clearly. Okay. Then you look at another important situations. Suppose if they are giving you like this situation, disproportionations reaction. N factor calculations, same formula. N factor calculations for same set, disproportionation, or comproportionations reactions. Same formula we will apply. For the same set, if the disproportionation reaction, what will be the n factor? For the same set, comproportionation reaction, n factor will be same. What is disproportionation reaction? So if forward direction disproportionation, backward will be comproportionation. So like that. What is disproportionation? Whenever one of the oxidation state is going to the two different oxidation state, one is lower and one is higher, that is called as a disproportionation reaction. Let us look one example. Like I2 in hot basic medium, it used to convert it to I minus and iodine and iodide ion, IO3 overall minus. This is the iodate ion, this is a iodide, and this is a iodate ion. Now, here oxidation state of iodine is -1, here oxidation state of iodine atom is +5. So now you look at elemental form, any element oxidation state is 0. So that's why you look at the 0, 1 is going -1 and 0 is going +5. So it's a disproportionation reaction. If forward direction is a disproportionation reaction, one of the oxidation state is going to two different oxidation state. One is lower, from -1 is lower than 0 and 1 is higher. So +5 is greater than 0. So that's why it is a disproportionation reaction. Now, if this forward direction is a disproportionation, backward direction will be a what? Comproportionation reaction. Two different oxidation state. That means if I minus plus IO3 minus is converted to I2, then it is called as a comproportionation reaction. That means two different oxidation state. If it is coming to the single oxidation state, it's called as a comproportionation reaction. So now, for the same set, for this set, either for disproportionation or for comproportionation, n factor always will be same. Now you look at for the same set, how can I calculate that disproportionation or comproportionation reaction n factor? You look at 1 by n factor overall, 1 by n factor overall, that means for oxidation as well as reduction. You look at 0 is going to the -1, oxidation number decreasing. So then it is nothing but a which process? Reduction process. Then here 0 is increasing to +5, oxidation number increases. Which process? Oxidation process. So now that 1 by n factor overall will be equals to 1 by n factor for oxidation plus 1 by n factor for reductions. Yes or no? So now this is the for disproportionation or for comproportionations. For the same set, we used to find out the same value will come, that overall n factor 1 by n factor overall will be equals to 1 by n factor oxidation plus 1 by n factor reductions process. And then same way, and always disproportionation and comproportionation, what way you have to think? You have to think iodine one time is converting to I minus, same iodine one time is converting to IO3 minus, then only you can put the value. Now you look at, for this process, this is a reduction process, I2 is converting. For this process, reduction process, for this process n factor will be equals to change in oxidation state into number of atom associated, always number of atom of reactant. So change in oxidation state 1 unit, and then how many atom associated over here? Into 2. So n factor for this process is 2. The same way here you look at that 0 oxidation state is going to the +5, change in oxidation state, and this is the oxidation process. So n factor for the oxidation, change in oxidation state is 5 unit, 0 to 5, number of atom, always look for the reactant, 2 atom into 2. So that means for this it is coming 10. So then we will apply this formula for disproportionation and comproportionation for same set, and same value will come in factor for same set disproportionation or comproportionation, what they are giving. Then 1 by n factor overall we need to get it for this process. For the oxidations we got how much? 10. So that's why 1 by n factor for oxidation 1 by 10 plus 1 by n factor reductions, which is nothing but 1 by 2. And then we have to do the LCM. So 10 and 2. So then 2 5 ja and 2 1. So then here it is getting 10. And then 10 1 ja 10. 1 plus. So then we are getting 6 by 10, which is nothing but a 3 by 5. That 1 by n factor overall is coming 3 by 5. Then n factor overall will be equals to nothing but a 5 by 3. That means for these disproportionation reactions, overall n factor is 5 by 3. Even for this comproportionation reaction, that means I minus plus I3 minus, if it is converted to I2, for this comproportionation reaction also n factor will be same value 5 by 3. Is it clear to everybody? I hope it is very clear to each and everybody. Then you look at another one example and then I will bind up. So if they are giving like this, like if you have like this scenario, potassium ferrocyanide FeCN whole 6, overall charge is how much? 4 minus. That means this is a one complex ion. Here cyanide ion is making a coordinate covalent bond with the central metal atom, and cyanide is a negatively charged. 6 negative, definitely iron has to be plus 2, then only overall charge is coming 4 minus, and it is converting to iron plus 3, as well as converting to carbon dioxide, as well as it is converting to NO3 minus. And then for this process they are asking you n factor overall for, this is called ferrocyanide ion, for ferrocyanide ion, ferrocyanide ion. Now you look at how we can calculate the n factor overall for ferrocyanide ion. So you no need to balance. Whoever is telling, they actually don't know in a fully manner. That's why they used to say you have to balance. No need to balance. Directly we will know if you know the concept properly. So now here, if you look at, now I analyze, iron plus 2 is going plus 3. That means this is undergoing oxidation. So this is undergoing oxidation. So let us say this is a oxidation 1. Now what about iron and carbon bond? That means carbon is forming a coordinate covalent bond. That means with the iron there is a carbon and cyanide bond is there, like this situation. And then iron is a metal, carbon is a what? Non-metal. Obviously for iron carbon bond, carbon will be what? Minus 1. And oxidation state definition is there. If you give bonded electron pair to the most electronegative atom, the imaginary charge developed on a particular atom is a oxidation state. Carbon is a non-metal, that's why carbon will take bonded electron pair. So like that there are, if you look at, there are 6 type bond also will be there like this. 6 bond will be coordinate covalent bond will be there with the iron. So then for this bond carbon is minus 1, but nitrogen is more electronegative than carbon. That's why these 3 covalent bond, nitrogen will be minus 3. For this covalent bond, carbon will be plus 3 for 3 bond. Each bond carbon will be plus 1. So that's why for each bond nitrogen will be minus 1. Like that 3 bond is there, nitrogen is minus 3, carbon is plus 3. That's why effectively carbon is there, each carbon is there, which state? Plus 2 oxidation state. Now you look at here, carbon is there is plus 4 oxidation state. That means it is also case of a oxidation. That means if you look at this carbon is going over here, this is another oxidation, this is oxidations 2. So now that means effective oxidation state of carbon is plus 2 is going to plus 4. So then here if you calculate, in the last we will calculate oxidation 1, oxidations 2 and another case of will be there also will calculate the overall oxidation state. Now what about the nitrogen? Now nitrogen here minus 3 each nitrogen, and now if you look at here overall NO3 minus nitrate ion, that means nitrogen is plus 5. That's why if you look at this nitrogen minus 3 is going to the plus 5. Here nitrogen is there in -3 oxidation state. So that's why this is also nothing but a oxidation. That's why I'm giving this is a oxidation 3. So that means all three component is undergoing oxidation. That's why overall N factor overall for ferrocyanide ion will be equals to oxidation 1 plus oxidation 2 plus oxidation 3 if I calculate the N factor. That means N factor for oxidation 1, N factor for oxidations 2 and N factor for oxidation 3. If you put, you will get the overall N factor. So then for oxidation process, for this one, N factor will be equals to change in oxidation state into number of atom. Change in oxidation state is 1, number of atom. Always look at the reactant side of what is the number of atom. So 1 into 1. For oxidations 2, same way N factor calculations. We will look at change in oxidation state plus 2 to plus 4, 2 unit change. How many atoms? 6. That type of carbon atom is there. That's why 2 into 6. Change in oxidation state into number of atom associated. Next one is, if you look at for oxidation 3 N factor calculations, we will do same method. N factor will be equals to change in oxidation state where -3 to plus 5 change is there. Overall change is there, 8 unit change is there. So like that, how many is there? Like that, there are 6 nitrogen atom is there. Change in oxidation state is 8 and like that number of atom associated which is 6. So that's why if you look at oxidation state 1, oxidations 1, N factor for oxidation 1 is coming 1, value 1. N factor for oxidation state 2 which is coming 12 and N factor for oxidation state 3 which is coming 48. So now overall N factor summations of all these, N factor for oxidation 1 plus N factor for oxidation 2 plus N factor for oxidations 3. So that's why this is coming nothing but a 61. So now whenever ferrocyanide ion is converted to iron plus 3, CO2 plus NO3 minus, then overall N factor for ferrocyanide ion is nothing but a 61. You look at without balancing we are doing always. Change in oxidation state into number of atom, always look for the reactant. Is it clear? I hope I able to give you clarity to yourself. To get more like these videos, come into my channel, give a comment, subscribes and look into this one. I will do more and more revisions for upcoming exam. Thank you very much. Thank you all.